Hello dear students, how are you? I hope you are doing fine and you are enjoying my online classes and you are studying your physics and practicing all the numericals. As you know, your term 1 is approaching very fast and we are doing the revision for chapter 12 and 13, which is your syllabus for term 1 examination. Chapter 12 current electricity and chapter 13 magnetic effects of current. We have discussed the derivations, the patterns of magnetic field, resistivity, resistance relation, Joule's law, fitting effect, Ohm's law, series and parallel combination of resistances. So all the syllabus have been covered already, but in revision sessions we are looking for more doubt clearing sessions and more numerical examples to discuss. So today, in today's lecture, I am here with you with the problems asked by the students of your class, and I have discussed them in online classes, but here is a video reference for you so that you can understand them better. Let us start with the problems we are having. The first problem is in calculating the resistance in various configurations. Calculating the resistance. So as class 10th student, I know that concept of series and parallel combination is quite new to you, but you have to understand this thing. I will give you an example which was asked by a class 10th student. Let us say we are having a combination of resistance in the form of square. Let us name it A, B, C, D, and the values are like 1 ohm, 2 ohm, 3 ohm and 4 ohm. The values are not same. If you are being asked what is the resistance between the points R, A and C, or what is the resistance between points R, A and B, or what is the resistance between points R, B and D, or what is the resistance between point R, C and D. So here is the important point. If the all values of resistance would have been same, then doesn't matter which side we are considering the square, the value of equivalent resistance would have come the same. But you can see that resistance are having different values, so these values may or may not come same depending on the individual values, whether they are same or different. Let us first calculate the RBD value. If you will look at the problem from the perspective of B and D points, then I would like you to notice this. When looking from the perspective of B and D points, you can see that from these 2 points, you can see because these 3 resistances are connected in series. See, one after another, then after another. So these resistances are connected in series. So for calculating RBD, what you will do, you will add these resistances in series, that is 2 and 1 3 and 4 7, and this 7 ohm value will become parallel with BD, and you can solve the value of RBD as 1 by RBD is equal to 1 by 7 plus 1 by 3, taking LCM 21, 7 3 is 21, 3 7 is 21, and you will get this value 10 by 21, or your RBD is equal to 21 by 10 ohm. So that is your resistance RBD 21 ohm. Similarly, if you are looking for RCD value and taking these 2 points of observation, then you can see now these 3 resistances are in series. Are you able to picturize it? When we are taking points C and D, we can see 1, 2 and 3 now are connected one after another in series because the point of observation has changed from BD to CD. Now look at this blue and circled 3 resistances. So for solving RCD, you will add 1, 2 and 3 in series. That will give you 1 plus 2, 3 plus 3, 6. So for calculating RCD, 1 by RCD is equal to 1 by 6, that is 1 plus 2 plus 3 plus 1 by 4, taking LCM 12, 6 2 is 12, 4 3 is 12, that is 5 by 12. So your RCD is equal to 12 by 5 ohm. So RCD is equal to 12 by 5 ohm. So you are observing how the resistances which are to be taken in series and then connected in parallel changes as you changes the points in between you are calculating the resistance. In the same value, when you will calculate RAC, then 2, 3 and 4 will become in series. 2 plus 3 5 plus 4 9, and you will join it in parallel with 1 ohm resistance. So 1 by RAC will come, 1 by RAC will come 1 by 1 plus 1 by 2 plus 3 5 plus 4 9, 1 by 9, and you can find the value of RAC. Similarly, your 1 by RB will become, this is your 1 by RAC, and your 1 by RAB will become 1 by 2, that is the top AB resistance, and then in parallel the series combination of these three, 1 plus 4 5 plus 3 8. So from this equation you can find the RAB. Now it is not necessary that every time you will be asked for the values which are AB, BD, CD or AC. The examiner might ask with you, I will draw the diagram again for you. A, B, C, D, 1 ohm, 2 ohm, 3 ohm and 4 ohm. Now what will happen if the examiner is asking about RAD point? What is the resistance RAD? Diagonally opposite point. The same method you can apply for RBC. So for RAD, now as the point have changed from AC to AD, now 2, 3, 4 are no more in series. Now you can see that this 2 and 3 is in series, and this 1 and 4 is in series, and their series combination is connected in parallel. So your 1 by RAD will become 1 by 1 plus 4 5 plus 2 plus 3 5. So it is 5 LCM, 1 plus 1 2 by 5. So your RAD will become 5 by 2 ohm. Similarly, if you want to find what is the value of RBC, then you can connect 1 and 2 in series and 4 and 3 in series, and then you can connect them in parallel. Look how the combination changes as you change your point of reference. So similarly you can write the 1 by RBD is equal to, for BD I am considering my black and circle resistances. 1 plus 2 is equal to 3 plus 3 plus 4 is equal to 7, taking LCM 21 3 7 ja, 7 3 ja, 10 by 21. So RBD value is going to be 21 by 10, because this is 1 by RBD, 21 ohm. And please take care, many times students do this mistake. They calculate the value of 1 by RBD and they write it as the value of RBD, and they forget to inverse the value, because in parallel it is for 1 by RBD. Coming to the next point of discussion, how to reduce a given circuit. That is a very good numerical. Let me draw the circuit diagram for you. We are having a 120 volt battery connected with a network as shown. Excuse me. and then we are having 2 ohm resistance, then we are having 1 ohm resistance, then again we are having 4 ohm resistance, and in between we are having 3 ohm resistance, and again we are having a 4 ohm resistance, and there is one more resistance in between having value 6 ohm, and it is required to find the current in 2 ohm resistance. Let us say current in 2 ohm resistance is, okay, we'll calculate it. And in this numerical, the current is being asked in particular 2 ohm resistance. But when I am going to solve this numerical, I'll teach you how to find the resistance current in any of the resistance, not particularly in 2. You can find current in 6, you can find current in 4, you can find current in 3, or you can find current in these 4 ohm resistances. What is the way to solve such problems? As we have already discussed the example of square and how to take care of the points between them we are taking the resistance, and how they change, which resistances are in series and then to be connected in parallel. So this is known as how to minimize this circuit. So after doing a little practice you will be able to do it more quickly. Let me help you. As the resistance is being calculated from the battery side, so these are your 2 points for looking into this circuit, and if from these 2 points you will look into this circuit, then you know if 6 ohm would not have been there, then all these 3 will be in series like previous square, but it is not the case right now because we are having a 6 ohm in between. So look from these 2 points perspective first, and on the outer side of the circuit you can see the 2 and 1 are connected in series, which is in parallel with 6 ohm, and then whatever their parallel combination will come, this value is, okay, first we solve it. That value is going to be in series with 4. Let us first solve these two values and let us see how our circuit reduces. So this is your 120 volt supply, this is your 4 ohm resistance, this is your 4 ohm resistance, and this is your 3 ohm resistance. I have not taken it, and 4 ohm resistance I have also not taken it. So when you will join 2 and 1 in series, your circuit will become like this. This is your 6 ohm resistance and 2 and 1 is in series. So you can write a single 3 ohm value in place of 2 and 1. Now you can see this 3, you can also draw it like this because it is connected between these 2 points only, 3 ohm, and it is very clear that the 3 and 6 are in parallel. And if I will replace this 3 and 6, two resistances in parallel, by a single value of their combination, I will not change the rest of the circuit. So 1 by R is equal to 6, 3 2 just 6, 6 1 just 6. So it's 3 by 6, or R is equal to 6 by 3, that is 2 ohm. So look carefully, I can replace these two 6 and 3 parallel combination between these 2 points. There is no other resistance, and I can connect a single 2 ohm resistance. Now again look at the problem from the perspective of these 2 points. Now you can see that these two resistances are connected in series, so it will become 6. 6 is again in parallel with 3, and 6 and 3 are parallel is 2, we already calculated. So your circuit reduces to 120 volt battery, 4 ohm, 2 ohm, the 6 and the 3 and the 6 in parallel, because 2 and 4 are 6, so their value will again come 2, and then we are having 4 ohm, it is connected like this. And now you can see from the perspective of battery, all these 3 resistances are in series, so the sum of the resistances will become 4 plus 2 6 plus 4 10 ohm. So your final circuit can be reduced like this: 120 volt battery and a single 10 ohm resistance, that is the equivalent resistance. So from this you come to this small circuit all the way, minimizing the circuit. Now you can calculate the current here very easily by Ohm's law. I is equal to V by R, that is 120 by 10, and that is 12 ampere. So here current is 12 ampere.